with differentiation is that when you graph something, so for example, is we graph this curve here, it's a U-shaped curve, okay? What you will find is that, and for argument's sake, this U-shaped curve goes through the point 1, 0, which will have to be somewhere like this, okay? So what we're saying is that differentiation actually gives you the slope of the graph. Now remember, when the slope is on, when the graph is going downwards, one sec guys. Okay, so if you imagine slopes are going downwards, and then after a while the slope starts going upwards again. Okay, so at different points the graph will have different slopes. So the steeper the slope, for example, is a slope of -3 would be 1 across and 3 down. So a slope of -3 would be quite steep, while a slope of -1/3 would be 3 across, 1 down, which is a lot less steep. So compare the steepness of the green line compared to the steepness of the blue line. The blue line would be a slope of -3, while the green line would be a slope of -1/3. So at different points of the graph, you could argue that this is more closely to a slope of -3, while down here would be more close to a slope of -1/3. The slope changes, okay? And what the great thing does about differentiation is that if you get the first derivative, you basically get the slope formula for any point you want. So for example, is on this curve here, what I find is, oh sorry, one sec, what I find is, I find the first derivative, so I get y equals x squared minus 3x plus 2. The y dx is 2x, so 2 times x is 2x, take away 3. This is the general slope formula, so the slope is always the first derivative. And to find the slope you're looking for, you simply insert the x value. So x equals 1 for this one, so it's going to be 2 times 1 take away 3. 2 take away 3 is a slope of -1. So what we're saying is when this particular graph, x squared minus 3x plus 2, goes through the point 1, 0, it's on its way down with a slope of -1. Okay, that means it's going down 1 and across 1 when it goes through the point 1, 0. Okay, so that's question 1 answered. Now we're on to question 6, because I did the other questions on the previous video. So that's what we're looking at. Okay, find the equation of tangents to the curve at these points and investigate if these two tangents are right angles to each other. Now, what we got to remember here is that we are talking about tangents, guys, okay? Okay, so here's what's going to happen. We have just to remember what right angles means, right? So if you have a slope of -1/2, which is 1 down, 1 down and 2 across. Okay, so a slope of -1/2, which would be roughly looking like this. A slope that's perpendicular to that hits it at a right angle. So I'll make a blue line. My blue line is the slope that's perpendicular to that. Would have to be a positive slope going across at 1 and up at 2. So remember, if I give you a slope of -1/2, turn it upside down, change the sign, and a slope that would be perpendicular to that would be a slope of +2. If I gave you a slope of 3/4, turn that upside down and get 4/3 and change the sign from positive to negative. So if you have a slope of 3 up, 4 across, like that, okay, a slope that would be perpendicular to that would be 4 down, 3 across, okay, and they'd hit each other perpendicularly, okay? So that's what you got to remember. And to show that they're right angle to each other, what you do is anytime you get two slopes, you basically, oh God, what did I do there? One sec, lads. So anytime you need to get the two slopes, and then you need to show that they are perpendicular to each other by multiplying them by each other and showing that they're equal to -1. we would have done this in the past. So for example, if we got a slope of 2/3 and minus 3 over 2, we know they're perpendicular, but we have to multiply them by each other. You get minus 6 over 6, which is minus 1, and you have to prove they're equal to minus 1. Now, this is a differentiation chapter, so we're going to show you what we need to get done here. Remember, the first derivative is the slope. So dy dx slope is first derivative. First derivative is 2x, bring the 2 to the front, take 1 away, differentiate minus 5x becomes minus 5. That's your slope formula. Now you're given two x's. You're given x equals 2 for the point 2, 0, and you're given x equals 3 for the point 3, 0. So let's try this out. 2 times 2, take away 5, is a slope of minus 1. Okay, and then 2.2 times 3 take away 5 is a slope of plus 1. So the first slope is minus 1, the second slope is plus 1, multiply them by each other, and you prove that they are perpendicular because the both slopes multiply to give you minus 1. Or they intersect each other at right angles. Okay. Now, question 7, we're hoping. Here it is. Show that the tangent to the curve 3x squared minus 4x plus 11 at the point 1, 0 is parallel to the line y 2x minus y plus 5. Now, there's a bit of geometry in this, guys. You remember the formula y equals mx plus c. Well, I got to get y on its own, so we're going to move y to the right, and we're going to get 2x plus 5 equals y. This is the same thing as y equals 2x plus 5. This means that the slope m comes in front of the m comes in front of the x, the 2 comes in front of the x. This means the slope is 2. Now, if they're parallel, okay, so we have a curve, this curve here, more than likely n-shaped or u-shaped. It goes through the point 110, which would be somewhere up here, let's say, for argument's sake. We see that it's on a positive axis, so we're hoping that the slope through 1, 0 looks like 1 across 2 up. And then there's another line, this line here, and it's over the other side, and we're hoping that both lines are parallel to each other, i.e. they have the same slope. Okay, so once again, we're going to go through the procedure of we're going to differentiate once. So dy dx equals, bring the 2 to the front to make it 6x, differentiate the minus 4x to get minus 4. This is the slope. The number we're using is x equals 1 because we can see the x value is here. So it's going to be 6 times 1 take away 4, which is 6 take away 4, which is 2. And the slope equals 2. Hence, they are parallel. Okay, and we're done.